Hello class, this is Dr. Ben, and let's work on an example problem out of chapter 4 that deals with the concept of kinematics. So we have this situation here with a rocket sled, and the problem talks about the rocket sled speeding up and then it slows back down. And so it looks like this is and so that means that we would need to have 3 different points of interest when we draw a pictorial representation. As we need the beginning and then the place where it switches from accelerating to decelerating, and then the point at the end. So let's go ahead and draw a pictorial representation for this problem over on the right hand side. So we'll pick an ordinary horizontal coordinate system. We'll put the origin towards the left, and I'll change to another color. We'll put the rocket sled at the origin to begin with, and then it accelerates for a certain amount of time and a certain distance, and then it continues to travel to the right until it comes to rest as it slows down. So we've got point number 1, and then we have point number 2, and we have point number 3, and we have the kinematic variables x1, v1, and t1. We have x2, v2, and t2. And then we have 3 and V3 and 3. We also have acceleration, so acceleration in the direction of motion, let's label that A1 from points 1 to 2, and then the second rocket sled slows back down, we'll label that acceleration A sub 2. Alright, so we've got that pictorial representation drawn, and now we can go ahead and make a list of what we know and what we want to find by using the numbers that are in the problem and our diagram. So let's start out with what we know. So the value of x1 equals 0. We start the car at the origin, and the rocket sled is at rest, so v1 is 0. Like usual, we can start the experiment at time 0. Alright, now we start reading the problem, and we see that the acceleration is 8 meters per second squared. Value of A1, 8 meters per second squared. For a distance of 16 meters, that would be of x2. 16 meters is x2. Alright, we continue to read. In what time interval should the rocket sled now be stopped so that the acceleration is 32 meters per second squared? So that 32 is the value of A2, the acceleration during the second part of the motion, and you notice that I wrote that down as a negative acceleration because the object slows down. The vector is opposite to the direction of motion. And the rocket sled stops, so the value of V3 would then be equal to 0. Alright, we want to find, it says, is the time interval that the rocket be stopped so that the acceleration has this value. So that's essentially the value t minus t2. That's how long the second part of the experiment takes. Okay, so now we're in a position to go ahead and start solving the problem using our kinematic equations. So let's move the paper up a little bit here, and Alright class, so we'll continue on with this problem. So remember that our goal was to figure out what the time interval was in which the rocket sled slowed down, and so that was from point 2 to point 3. But what we're going to need to do is to find the velocity of the rocket sled at point 2, because we're going to need to be able to use that in order to figure out how long it took to slow down. So we need to go back and consider from point 1 to point 2, and we want to try to find the value of the velocity at point 2 from the given information, because that will be very useful. So we don't know anything about the time for the first part of the problem. So there's only one of the three kinematic equations that doesn't have the time in it, and that's the equation that has the squares. So we would take the final point being point 2, v2 squared is equal to v1 squared plus 2 times a1 times x2 minus x1. And so for our situation, we know that the value of v1 is equal to 0. We know the acceleration for the first part of the motion is 8 meters per second squared, and then x2 minus x1 is 16 meters, and that's given. So I get my calculator out, and I'll take 2 times 8 times 16. So that's 16 squared, which is 256. And so v2 would be the square root of that, so which would be equal to 16 meters per second. So that's the velocity of the rocket sled at the end of the accelerating phase. Alright, so now we can go ahead and actually finish this problem and do the part that we want, which is really from part 2 to part 3. So we want to find out something about the time, so we want to use an equation with the time, and we now know the velocity at the beginning and the end from 16 meters per second down to 0, and we know the acceleration for this part of the motion. So the equation that has the velocities in it and the time would be the most appropriate one to use. So we could say that the final velocity, which is v3, is the initial velocity, which is v2, plus the acceleration, which is now labeled t2, times t3 minus t2, which is exactly what we want to find. So the final velocity is equal to 0. The velocity at point 2 is 16 meters per second, minus 32 times t3 minus t2. So obviously then that has to be equal to 1/2, because 1/2 times 32 gives us 16. So that would be 0.5 seconds. So it takes this rocket sled then a half a second to slow back down to rest after it accelerated for the first part of the problem. And to finish this up, we'll check our units, which I have seconds for a time, and my significant figures. I believe that all of the numbers that we started with were two-digit numbers, so this could probably be written as 0.50 seconds with two significant digits.